Dear student, in this class we will discuss physical properties of alkyl halide. Already we have taken some method of preparation of alkyl halide, and now properties of alkyl. We will discuss the properties of alkyl halide, various properties. Now, first physical properties of alkyl halide. Okay, see, in case of alkyl halide, any alkyl halide, halogen atom is directly attached to carbon atom. Okay, aliphatic carbon atom. Now, what happened? We know this bond is formed by sharing of electron. Carbon halogen bond is formed by sharing of electron. Okay, one electron given by carbon and second electron given by halogen atom. They have shared their electron and form covalent bond. Now, we want to discuss the nature of this carbon halogen bond. We know electronegativity of halogen is quite larger than electronegativity of carbon and hydrogen. Electronegativity is higher means what? The electron attracting power of halogen atom is larger. Electron attracting power nearby electron, whatever electron present in its surrounding, they have power to attract that electron. So its power is larger than carbon and hydrogen. So what happens if power is it has more power to attract electron? Then what is the effect? See, this halogen atom attract electron towards halogen atom. Then this electron gets shifted toward halogen atom. Okay, halogen, now they are very close to halogen atom and somewhat away from carbon. This is the middle part of this bond. Now bonding electron pair shifted toward halogen, therefore electron density of halogen increases, means negative charge increases. So automatically partial negative charge will develop on halogen. At the same time, electron density of carbon decreases, because among these two electrons, one electron was given by carbon during bond formation, that is also displaced toward halogen. Therefore electron density of this carbon will get reduced, and so the effect is that partial positive charge will develop, means carbon halogen bond, halogen carrying negative charge and carbon carrying partial positive charge, equal partial positive charge. So this is the bond in which one end is partially positive and another end is partially negative, means dipole. This is dipolar molecule, or bond is dipolar means they are polar bond is polar, which it means molecule is polar molecule. So alkyl halide is a polar molecule having polarity, and due to this polarity various physical properties of alkyl halide will change. Okay, various physical property will depend upon this polarity. Due to this polarity, melting point change, boiling point change, their reactivity also going to change. Okay, many properties have been changed due to polarity. Now see, lower member of alkyl halide like methyl chloride, methyl iodide, ethyl iodide, they are in gaseous state. Okay, some lower members are exist in gaseous state, but higher means having more number of carbon, hydrogen. These higher members are liquid, and again some of them are solid also. Okay, so lower members are gaseous in state, but if we move from lower to higher, then in middle part some member are exist in liquid state, and then higher one are exist in solid state. Okay, so why lower member having poor molecular interaction with each other, their intermolecular distance is quite large, that's why they are exist in gaseous state. If we move to lower to higher, what happen? Polarity also remains same, but as the carbon atom and hydrogen atom increases, van der Waal force of attraction increases. Van der Waal force of attraction increases between the molecule. This force is depend upon the molecular mass. Higher the molecular mass, higher will be the van der Waal force of attraction. And due to this van der Waal force of attraction, the molecule of alkyl halide come close to each other. Therefore, intermolecular distance decreases, and therefore this molecule exists in liquid state. And again at higher member, in case of higher member, then van der Waal force of attraction again increases. Therefore, molecules are now very close to each other. That's why these become solid. Okay, so this is due to force of intermolecular force of attraction. See, melting point and boiling point of this alkyl halide are quite larger than normal alkane or normal hydrocarbon. Why? This is due to the fact that alkane or normal hydrocarbon having no polarity. Polarity is 0. They are non-polar molecule. Therefore, intermolecular force of attraction is very less. That's why their melting point, boiling point are low. But in case of alkyl halide, we know alkyl halide Rx, alkyl halide molecule having polarity. Due to this polarity, various molecules are interact with each other, form bond. Intermolecular electrostatic force of attraction exists between them, and therefore, and also this alkyl halide molecule having two type of forces present among them. One is van der Waal force, okay, and another force is electrostatic force of attraction due to polarity. Electrostatic force of attraction due to polarity. Therefore, these molecules have quite higher force of attraction between them. Interaction is more, and therefore more energy required to break this bond and separate them. Therefore, melting point, boiling point of alkyl halide are quite larger. Okay. Now, if we discuss melting point and boiling point, from lower to higher, melting point or boiling point increases. Why? This is due to the van der Waal force of attraction. From lower to higher, molecular mass increases. Therefore, van der Waal force of attraction increases. Electrostatic force of attraction remains same, because if halogen atom same, okay, then only increasing factor is van der Waal force of attraction. As the van der Waal force of attraction, the interaction will be more among them, and more energy is required to separate them. Therefore, melting point, boiling point increases. Okay. Again, in case of isomeric alkyl halide, one bromobutane, two bromobutane, like this, or tertiary butyl bromide. Among these, if we consider these three alkyl halide, see, this is 1-bromobutane. Okay, second one, 2-methyl 1-bromobutane, propane means, and tertiary butyl bromide. See this. All these three having same molecular formula, C4H9Br. Okay, all these three compounds having same molecular formula but different arrangement. They are isomeric in nature, isomers of each other. From 1-bromobutane to this branch, here branching is 0, no branching. Here single branching, and here two branching, double branching. So as the branching increases, okay, the surface area of the molecule will decreases. And van der Waal force of attraction is depend upon surface area. Higher the surface area, higher is the van der Waals force of attraction. Remember this. So higher the surface area, higher will be the van der Waals force of attraction. But so from 1 bromobutane and 2 methyl 1 bromopropane and this tertiary butyl bromide, surface area decreases, right? Surface area decreases from this. As the branching increases, surface area decreases. Therefore, van der Waals force of attraction decreases, and van der Waals force of attraction decreases means interaction is poor now and less amount of energy required to separate them during boiling or melting point. Determination of boiling point or melting point. So branching increases, melting point, boiling point also decreases. Remember this. Okay. Again, they are soluble in organic solvent, easily soluble in organic solvent, but they are sparingly soluble in water, or mostly higher member are insoluble, but lower member are quite sparingly soluble in alkyl water, because they form bond, hydrogen bond with water, and that's why they are slightly soluble. Okay, so these are the some physical properties. Now we will discuss chemical properties of alkyl halide. Chemical properties. Chemical properties of reaction. We will discuss the reaction of alkyl halide or application of alkyl halide. What type of chemical compound we can prepare from alkyl halide. Okay, we know alkyl halide molecule is a polar molecule, so definitely these are reactive compound. Reactive, self-reactivity. Having self-reactivity is quite reactive than normal alkane. Okay, why? Because they are polar. Alkyl halide are polar molecule having partial positive negative charge. Therefore, they have high reactivity than normal hydrocarbon. Okay, so it is found that alkyl halide molecule normally shows two types of chemical reaction. One is substitution reaction, and second one is elimination reaction. Okay, elimination reaction. Normally all alkyl halides shows substitution reaction as well as elimination reaction. Okay, now first we will discuss elimination reaction, substitution reaction of alkyl halide. Give heading substitution reaction of alkyl halide. See, we know alkyl halide. This alkyl halide, it is very easy to replace halogen atom by another group, another atom or group of atom. Then we get this. Okay, this type of reaction is called substitution reaction. Very simple to replace halogen atom from alkyl halide by another atom or group. Why? So this is just a simple substitution reaction. Now in substitution reaction there are four types of substitution reaction: aliphatic electrophilic substitution reaction, aliphatic electrophilic substitution reaction, aromatic electrophilic substitution reaction, aromatic nucleophilic substitution reaction. But in this reaction, our reactant or substrate reactant is aliphatic. Okay, not aromatic, it is aliphatic. So this reaction may be aliphatic electrophilic substitution reaction or aliphatic nucleophilic substitution reaction. That we have to identify. What is the type of reaction? See, this Y is going to replacing halogen atom from alkyl halide. Tell me what will be the nature of Y? This reagent Y. Reagent are of two types, either electrophile or nucleophile. What is Y? See, this halogen atom is negative and Y is approaching this R and replacing X. So we know R is already positive. So Y is approaching them. Y in this reaction, Y is attacking on R and replacing X, attacking on partial positive charge containing species. So Y must be negative. Y must be negative. Negative means nucleophile. So alkyl halide molecule undergoes aliphatic nucleophilic substitution reaction. So this type of reaction is called aliphatic nucleophilic substitution reaction, or in short substitution nucleophilic substitution reaction. Nucleophilic substitution reaction or SN reaction. In short, SN reaction. SN reaction stands for nucleophilic substitution reaction. Here reagent Y is negative, replacing halogen atom from this alkyl halide molecule, so giving this type of product. This is the nucleophilic substitution reaction. So dear student, in next coming class we will discuss the various example of nucleophilic substitution reaction one by one. Thank you very much.